Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we'll be talking with Eric McDonnell, principal at Holmes, an interdisciplinary engineering firm. As a native of the Pacific Northwest, he has a natural affinity for mass timber projects and thrives on helping realize sustainable structural solutions. And in this episode, we'll be talking with him about mass timber and his time working abroad and how it's helped grow his engineering career. I'm your co-host, Matt Picardal.
And I am your co-host, Rachel Holland. Now let's jump into the conversation of the week with Eric. Eric, welcome to the show. Can you tell our listeners just a little bit about yourself, introduce yourself, and give a background on your career sort of up to date?
Yeah. Well, I grew up in Oregon in the Pacific Northwest. After high school, decided I needed a break from the rain and headed down to California, where I went to Cal Poly, actually with Rachel here on the call with us. So I've known her for a long time. So excited to be here. And then from there, I went down to UC San Diego for grad school, and then eventually up to San Francisco, where I worked for 6 years prior to moving over to New Zealand after the earthquakes in Christchurch in 2011. And then I came back to Portland in 2013, and then in 2019 helped open an office for Holmes Structures in Portland. And then just recently, within the last year, I've become the director of mass timber for Holmes, kind of overseeing all our mass timber projects up and down the West Coast.
Thanks for that, Eric. And I understand, from talking to Rachel too before the call, I know you did a lot of volunteer work early on in your career. Can you tell us a little more about that and how you found it valuable and how it shaped your career?
Yeah, well, back in 2007, a good friend of mine invited me to a meeting with Engineers Without Borders. I didn't really know what I was getting into at the time, but I was really just impressed by the organization and the work they were doing. And then we're looking around for opportunities where, a young structural engineer can make an impact. And we found a project in Haiti where they were hoping to build a health clinic. And so got connected with that project and the community there of Bayonne, which is kind of near Gonaïves, sort of the center part of Haiti there, and started working in this valley that had about 80,000 people, very little electricity, very little running water, and no health clinic for that whole valley. So definitely saw the need there. And it was a long project, a lot of work, worked with a lot of great people there. And then partway through the design of that health clinic, there's actually the big earthquake in 2010 in Port-au-Prince. And so that kind of put a little hold on everything, and also was able to connect with some organizations and do some volunteer work in Port-au-Prince right after the earthquake, basically doing earthquake assessments of schools and health clinics and individual homes in and around Port-au-Prince. So that was really an eye-opening experience for me. And then after that, kind of went back to working again with this community in Bayonne, and actually finished the design, and I helped with a lot of the construction efforts of that clinic, which was finished in about 2011, 2012. So just a really rewarding experience to be able to get out there and help people and put our schooling to work. So yeah, that was great. And then I think one of the other things that really opened my eyes was I think we don't necessarily have an appreciation for how buildings are built in different parts of the world. Certainly not the construction methods that we learned in school. But I did learn more about techniques that sort of cost-effective techniques that could still have some seismic resilience. And one of those was confined masonry. So I really studied up on that a lot, and that was one of the things that we wanted to implement into this health clinic, because we felt it was something that was more repeatable in this sort of environment than trying to build buildings like we would in the US.
Good thing
It's really
you have
interesting.
good friends that recommend these projects for you.
That's right. Yeah.
Is that you, Rachel, that dragged them into the meeting? And
Yep. Yeah. Well, and we could edit out this part, but they wouldn't. Rachel's mom wouldn't let her go. So.
Well, she gave you the opportunity.
Yeah. But
yeah.
I mean, I think like many people, I went into I was very idealistic coming out of university and wanted to do, I was really thinking that this profession gave us an opportunity to give back and have a safer built environment. And this was just one of those opportunities that allowed me to do that. And it was very fulfilling. I mean, and then also from a career aspect, it opened more doors. It gave me exposure to more individuals in the industry, and broaden the future opportunities. And my encouragement would be to do this when you're young, because once you have kids, it's a whole lot harder. So you're either going to do it when you're young or when you're old. And I'd highly suggest to get involved in something like that as soon as possible.
So you got to go to Haiti a few times with that organization and work on those projects. And then a little bit later in your career, you actually, after the Christchurch earthquake, you took a big jump and went over to New Zealand to work. So can you tell us a little bit more about that experience, how you helped to rebuild, and just kind of like what you learned from it?
Yeah, I mean, I think that was really just an amazing experience to live and work overseas and to experience how people design differently. And I would say New Zealand's a really special place when it comes to structural engineering. Some of our brightest structural engineering minds have come out of there, and just worked with a lot of great people and some of the smartest individuals that I've known in the profession. So that was amazing. It was also a real big very big difference in going from a post-earthquake zone in Haiti to a post-earthquake in Christchurch. There's the buildings that are built that were built in and around Christchurch are very similar in a lot of ways to the way we would typically build in the West. So there was a lot more, I guess we could direct learnings from the sort of the damage observed there to the type of work that I do now here on the West Coast. I think the other thing, it was just very eye-opening to see the impact that a major earthquake can have on a mid-sized city like that. The whole downtown of Christchurch was closed for almost 2 years. And it's only one of the few times in my life where that little professional engineer's card was really valuable, because to get into the red zone there, you needed your engineering certificate or be with the military. So that was a first and probably the last.
Kind of like a VIP card. Hey, do you know who I am?
Yeah, something like that. But and then just watching 1,000 buildings get demolished in a city, and there's something very sad about that, and definitely wants you to design and be able to build better. It also also showed me just how resilient I think people are, despite this major disruptive event. Life did go on, and they did rebuild. The house that I lived in, had duct tape on the walls. The windows were broken. The chimney had fallen off. Had an amazing ocean view. But and even our sewer was coming out of the house was a fire hose for a long time. But again, people are resilient, and communities are resilient, and so that was just an amazing experience and something to see.
Yeah, I know I know a lot of structural engineers don't get to actually experience firsthand, I'd say, the importance of their designs, but it seems like you've gotten that where uh, even when with Haiti and New Zealand, uh, I'm sure you've learned a lot of lessons with, I don't know, concrete shear walls. You said they had, I know they did a lot of research in Christchurch too, or a lot of case studies that they learned a lot of lessons from. But I think seeing it firsthand, oh, this is why we design concrete shear walls this way or structural system this way, because we've seen the lessons that have actually occurred. And I just thought that was interesting, since I've never gotten to see it firsthand, but I imagine that would give you a greater appreciation for the engineering that we do.
Yeah, I mean, I think that's absolutely true. It really kind of brings it down to earth, the implications of what we're doing on a daily basis, and sort of the impact we could play. Obviously, who knows when that's going to get tested, often in our lifetime. And so none of these were, actually buildings that I designed, but easily could have designed something similar. And it's it was definitely a learning experience. Certainly put my ATC training to use over that 3-4 year period.
And I know you also spent some time in Portland. You've been involved in the engineering of over 30 mass timber buildings, either built or under construction. As an early adopter of mass timber, how have you seen the industry evolve throughout the years? I know it's getting more and more traction, especially with the codes as well.
Yeah. I mean, I think when I first started designing with mass timber, there's essentially no guidance in the US. We were looking to what was getting done being built up in Canada, maybe a few of those design guides, what was coming out of Europe, and just trying to really soak in as much as we can, and then try and bring that into a US context, specifically around seismic. A lot of the work in Europe just wasn't dealing with seismic in the same way that we need to, on the West Coast. So that was one thing. It's come a long way. There's a lot more guidance out there. There's some of it that I've been lucky enough to be involved with. Some things around like CLT diaphragm design, for example, and vibration design of mass timber floor systems, and then also some research on some new seismic systems. So I guess again, it's just really going from almost no guidance out there to a lot. There's a lot of education early on that we were involved with, on the owner side, on the jurisdiction side, and on the builders. And I think that people's general familiarity with mass timber is grown a lot, and so we don't have to do as much of that education as we used to. That said, still do quite a bit, particularly when we're working in as we broaden our reach, and where we're doing mass timber projects across the US.
When it's such an interesting thing, because I know you're saying like it's becoming more popular, so you don't have to do as much research, but it's still exciting because it's a new product and a new look and a new way of building, and it's slowly like trickling down in the United States. So I still think it's pretty exciting. And I wanted to ask you a little bit more about the research that you did for the NSF. It's the NSF NHERI. Do you actually say it aloud, or?
No, it's a NSF NERI Tall Wood
NERI,
project.
okay, that's what okay. So yeah, the NSF NERI Collaborative Research Project. So you were doing that to develop resilience-based seismic design methodology for tall wood buildings, right? Can you tell us more about that project?
Yeah, well, one of the earlier projects that I worked on was the framework project, which was going to be a 12-story mass timber building in Portland, and it was one of the winners of the original tall wood design building competition. And as part of that, we proposed a resilient design, and I think this is also coming a lot out of the aspirations that of post-earthquake Christchurch and wanting to design more resilient and low damage buildings. But anyway, the system that we came up with for that building was a post-tension CLT rocking wall system. And we saw it as a system that could meet those goals and be an all wood solution for this project. And that was really the aspiration. Sort of in parallel with that, there's a couple of researchers, John Vanderlint at Colorado State and Jeff Berman at the University of Washington, and Shilang Pei at Colorado School of Mines. And Shilang is the sort of the lead investigator for that project. But they were trying to look at, what would be a resilient mass timber system for tall wood buildings. So because of those parallels, we started working and collaborating a lot and sharing ideas. And then we did a lot of project-specific testing for the framework project, which was permitted. It just, unfortunately not built. But we were sharing information, and Shilang Pei asked us and me and a colleague to get involved, Reed Zimmerman, in this research project, and we provided a lot of input, particularly on the 2-story test, which was a really successful test a few summers ago, which tested a full-scale 2-story version of this post-tension rocking wall system. It also tested the CLT diaphragms, and then since then there's been a lot of other research sort of at more the component level scale. But what's going to be happening in the first quarter of this next year is actually testing a full-scale 10-story version on the shake table down in San Diego, and that's built out right now, and it's really exciting. I'm going to go down and see it in a few weeks myself. Yeah, I think there's a lot of different partners that have worked on that project, and there's a lot of anticipation on watching this building go through some simulated earthquakes.
That's so cool. Is there any way to see those tests? Is it available on the UCSD website?
Well, if you go on the UCSD website, there's a webcam on there, so you can see the construction. And I'm sure there's going to be some live streaming during some of the tests as well. So definitely stay tuned and pay attention to that. There is also a NERI Tall Wood website where you could go and learn the latest about the project. And I imagine there'll be some links on there on how to watch the testing live.
Yeah, very cool. Yeah, it's not every day you get to see a full size or almost full size scale get tested on by earthquakes. So that should be interesting to watch.
Yeah, well, and my understanding is it's going to be the tallest building ever tested on a shake table.
Oh, really?
So not only the tallest wood, but the tallest, right?
Yeah, 10 stories. And UCSD's shake table, I believe, is the second largest or maybe the largest outdoor shake table. So yeah, it's really something. And
yeah, and it's just been upgraded, recently to have more degrees of freedom. So that first test that we did was primarily in one direction, and this will be multi-directional test. So it's it's pretty exciting.
Yeah, that's going to be cool.
I know Simpson's been involved in that also, not me personally, but I get some updates every once in a while. So that's definitely exciting. Looking forward to seeing how that all comes together at the end.
Yeah, so Simpson has certainly been a major partner for making that project happen. And I know there's a number of specific connectors and different things that are been developed by Simpson that are going to be in that test as well.
And why do you, from an owner's and architect's perspective, why do you think mass timber is gaining more and more popularity in the industry?
Yeah. I mean, I think personally, I think number one is just the look and the feel of the buildings. We're in a 6-story mass timber building ourselves, the district office building in Portland, and I can tell you it's a really enjoyable place to be and work. When you compare that to our office buildings of old with drop ceilings, drop tile ceilings, it's a world of difference. So I think that's one. I mean, there's certainly a sustainability tilt to it too. I think we're starting to recognize more and more, the carbon footprint of our new buildings, and I think timber certainly has a place there to help reduce the global warming potential of our buildings. I think another one that we're seeing, especially with office space right now, is that a lot of developers see it as a market differentiator. There's a lot of vacancy rates out there, and if you're going to build an office building, you need to do something a little bit different. Something that's going to draw people in and want them to be in that space.
I did take a tour on one of the mass timber buildings. I believe it was might have been the Microsoft headquarters, I believe. But yeah, taking a tour of that, it does feel different, and I could definitely say like, oh, this is a different type of building when you get to see the wood columns and the CLT floor slabs. It kind of gives it, I don't know, a more organic or wood look, but it's different for sure. So yeah, I think I can see the appeal in that.
I think one nice comment I've heard is that no one's ever gone and hugged a concrete column, but
that's a good one. Yeah, that's true.
For our next podcast, you're gonna have to take us around your office building, like crib style, like bring us in and show us all around so we can see how just the difference.
I was trying to figure out how to do that for this, and maybe I could send you some photos or something that you could sprinkle in, but I actually really like it a lot. For our typical calls we have, I'll do it in the office space, and you just have the timber background. It's pretty nice and effective, especially when you're talking about in the middle of designing another mass timber building.
Right. Yeah, that's perfect. What about in terms of mass timber and like the rising the questions of like cost, right? And long-term sustainability, how can you make it applicable in different environments? What are your opinions? What do you think the future holds for mass timber?
Yeah, I mean, it's a great question. I certainly don't think, again, it's kind of going back to, started this very early on, working with mass timber, probably 2014. And, there's a lot of excitement, but it was very new. And a lot of people were thinking, oh, is this just going to be a fad and it's going to disappear? And I think the answer that we see is, absolutely not. It's something that I think is going to stick around for a long time to come. There's certainly some major players in the industry that are, interested in that. Matt, you mentioned the Microsoft campus, which our San Francisco office was, the Mountain One and Mountain View was involved in. And then, obviously a number of projects by Google and a number of the other tech companies. Worked on a project myself for Adidas here in Portland for their North American headquarters. And so it's just a huge interest, and I think it's going to grow rather than anything else. I think obviously there's questions about, how much can it grow? And I certainly don't think we're going to get to a point that every building's built out of mass timber and it's replacing steel and concrete. I think it's just one of the tools, and one that I happen to really like, that is going to go towards a better built environment. In terms of, supply and sustainability and sourcing and all that, there are certainly people that know more about this than I do. But I would say that wood is pretty special in that it's the only material that we use that can be grown by sun and water. And there's something that's pretty neat about that.
My last question, just to end off here, do you have any final piece of career advice for structural engineers, whether they're students or maybe they're already in the profession for a couple of years?
Yeah, I think one thing that I've observed and noticed through my time is it feels like, a lot of engineers, or most engineers will get, one or two opportunities in their career that they could seize on. My advice would be to look for those opportunities and to seize on them when you can. For me, it happened to be, mass timber. It happened to come around at the right time when I was looking for something new, and I had the right skill set to do it. And so, but I easily could have, let that pass and regretted it later. So that would be my one piece of advice, from that perspective. The other thing I would say is just find a really good place to work that you enjoy and feel valued. We spend probably more time with our coworkers than just about anybody else, and it's important to be around people that you like and trust and just enjoy being with. And so those are sort of my two things. I'm sure I got more, but
great advice.
Yeah, thanks for that advice, Eric, and for sharing all of I guess your structural engineering journey. That's definitely unique, going to Haiti and Christchurch and getting involved in the research and being one of the early adopters of mass timber too. Yeah, thanks a lot for sharing. And I think, the advice definitely. I think, working with people that you like, you'll be there with working with them for a bit and taking advantage of those opportunities. So, great advice, and thanks again for coming on.
Yeah, well, thanks for having me, and I certainly do feel fortunate, and it's good to have conversations like this to remind you of, I guess, how fortunate you've been with opportunities in your career. So, it's great talking with you both.
Thank you, Eric, for coming on.
All right.
I appreciate it.
Yeah, thanks, Matt. Thanks, Rachel.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 95, as well as the links to any of the resources or websites mentioned during the episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.